what I'm going to kind of give you this algorithm in 3 different ways. We're first going to look at the Reader's Digest code, which is amazingly short. And then for whatever reason, I got addicted last year. I gave them an assignment where they had to fill in a spreadsheet. And so I did another spreadsheet, and we'll go through how to do it in the spreadsheet. And then we'll look at the longer version of the code. Okay, so you ready for the short version of the code? There, that's the code. You can't get much shorter than that, can you? All right, so the various parts of the code that we have to understand are, first, how do you set up this table indexed by the subinstances? And then you have to, one thing that often people who are used to recursion do is they think that the base case is an if statement. If I'm the base case, then I will do what? No, but this is, we're filling the table. So we never recurse, and you always start by filling in the base case into the table, right? So we'll fill in the base cases, then we'll loop over all subinstances, right? Because we have this table, and so we have to fill in every instance of the table, and the table is indexed by these subinstances. So we're basically looping over the subinstances from the base case all the way up to our final instance, right? That makes sense? And remember, what do we do for a particular subinstance is we try all the bird answers. So there's going to be this inner loop where you loop over bird answers, right? And then what do you do when you have a particular subinstance you're trying to solve? Your bird has given you some advice. Well, then we're just down to kind of the bird friend algorithm, where we have help from our bird, we get help from our friend, and we combine them, right? And then after you do all the bird's answers, now we have the best solution for each bird answer. We have the best solution consistent with that bird answer. So we take the best of the best, and that's the entire algorithm. All right, so let's see how that connects. First, we have to set up the table here. What are our subinstances? There's our table, right? For each node VI, we have a subinstance. What is the shortest path from S to VI? These guys, that? Yeah, that's an equals. All right, so then we need to set up, solve the base case. The base case is what's the shortest path from S to S? And well, it's kind of the no path, and it has cost 0, right? So here, I guess I'm storing the solution. I'm saying it's kind of the 0 solution, right? So we put that in, and then we loop over subinstances. So here we're filling in some of these instances so far, and now we're ready to solve this one here, right? And when we solve this one here, what we do is we loop over the bird answer. So here I'm looking at, give me every sort of edge from yeah, these slides, I would turn this around. Let's turn it around. We had various versions of slides over the years, and I guess I grabbed this. I don't like it quite as much as what I want. All right. Yeah.
That's another reason, right?
Here, let me explain it before you ask about it. All right, so here, what are all the bird answers? She is going to tell you, all right, we're trying to solve this problem, and she's going to tell you the last edge. And I usually have K denote the answer the bird gives. And so in some ways, it's the index of one of these nodes up here, because it's an edge from VK to VI, right? We're looping over all the edges that are coming into our node. We're currently working on node I. We're trying to find the best path for I. And so the bird tells us all these edges coming into I, right? So those are the various answers she might give. And now when she, we move these guys around. So this is going to be our friend. And this one is going to be our bird, because we switched them, right? All right, so here, well, this, what is this here? This says we ask our friend, right, for, let's bring them all in, right? So we ask our friend for the path, the best path to V. What are we storing in here, right? We're storing the optimal solution, which is the best path from S to VI. So this will be the best path from S to VK, right? And so here, it's this 6 here is the length of the best path from S to VK. And then the bird gives us the edge from VK to VI, right? Does that make sense? So in the end, that's kind of, right? Here we have a sum. Our friend tells us this number, and the bird tells us the weight of this edge or this edge, and we put the two together, right? Does that make sense? And then after we've done that for each of the bird answers, we take the best of those and we store it in our table. Right? People good with that?